y'all. I'm Emily, she, her, hers, and today I'm making a video I meant to make a really long time ago. I'm really sorry it didn't happen. Hopefully talking about multinomial coefficients is helpful while studying. I also want to say we're going to be better about videos for material after midterm 2. They'll become a lot more useful. Counting is just so weird. It's hard to make useful videos. But after this midterm, it's much more focused ideas and it'll be easier for us to make helpful videos. So check those out while you're doing homework. And now to get started, we're doing multinomial coefficients. If you feel like you already know these, I kind of suggest you stick around because there'll be useful stuff of just how we think about these, how they're different than stars and bars, kind of complicating and like making sure we understand the general idea of when to use them. At least that's my suggestion. You do you. I'm going to start with like the very first multinomial coefficients problem we learned, but then I'm going to complicate it a little bit. And I'm just going to start with 3 A's, 2 B's, 2 C's, and we're putting them in a string of length 7. I cannot count 4, 5, 6, 7. You know, if we were putting letters in a string, you normally use 7 factorial, but there's not 7 options for the first spot to have that look different. There's only A, B, or C. So we don't want to do that. The way I usually do it is the combination way. 7, choose 3. Think about, you know, maybe we put 3 A's, choose the spots we're putting A's in right here. Choose 2 spots for putting B's in and 2 spots for C's. Maybe one example string would look like this. If you use the combination formula, you get this kind of simplified, nice looking thing that we've seen in lecture. I don't really use this. I just know that the combination is equal to it. The left side is, but you do you, like, the left side is thinking in terms of combinations. If you like that, go for it. The right side is thinking in terms of permutations, like 7 factorial is a permutation, 7 permutes 7. So if you like permutations divided by permutations, have at it. Okay, the part where I complicate this just a little bit is I really more think about this problem as an indistinguishable objects, distinguishable boxes. You know, we have 7 letters, letter 1, letter 2, all the way to letter 7. And like this spot is for letter 1, this spot letter 2, all the way, again, letter 7. And then the letters get put in boxes called A, B, and C. And then we can tell them apart between the boxes, but we can't actually tell them apart within the boxes. This is the same kind of thinking where we can't tell chocolate donuts apart from other chocolate donuts, but we can tell chocolate from strawberry donuts. So this is the same kind of thinking as stars and bars, actually. But the difference is that we've said there's only 3 objects in box A, for sure. Only 3. 2 in box B and 2 in box C. Stars and bars would count where there could be 7 in A, 0 in B, and 0 in C. But it would also count the case where there's 3 in A, 2 in B, and 2 in C. So because they're set in stone, this is not a stars and bars problem. But it is an indistinguishable objects, distinguishable boxes problem. It's just that our boxes are set. And now, you may or may not remember from lecture though, we did another problem using multinomial coefficients. And it was with distinguishable people who all look different, being put into taxis, 3 different taxis where we can tell them apart. And like, wait, I just said this was an indistinguishable objects problem. But people are distinguishable. That's a distinguishable objects, distinguishable boxes problem. And you're right, it is. And let's think through why we still use multinomial coefficients for that. So, I kind of ran out of space, whatever. Let's think about if we have the letters, these 7. They're all different letters, they're distinguishable. Yes, I had to sing the alphabet song to know what the last 7 letters of the alphabet is. I'll admit it. But we have these 7 letters, and we're putting them in 3 different boxes labeled A, B, and C. We want 3 in box A, 2 in box B, 2 in box C. And now we can think about this as filling the boxes. I have 7 options that could go in box A. I want to choose 3 of them. Now I have 4 left, put 2 in B, and then 2 in C. And this is the same combination we did up here. But our thinking was different. You know, up here we were choosing spaces, and now we're just choosing stuff to fill boxes. That's weird. But I'm going to say this choosing of boxes, we can think of choosing as spaces. And what I mean by that is we're really calling each space in a list a letter. And then in each blank, we want to put either A, B, or C, depending on which box a letter is put into. And so 7 choose 3. One example it chooses is it picks the letters V, X, and Y and sticks them in box A. And then 4 choose 2 might pick T and W to put in box B. And 2 choose 2 picks U and Z to put in box C. This is the same string we wrote up above, like actually the exact same string. And even though each letter here is different, what we really care about is the different strings we can make with 3 A's, 2 B's, and 2 C's. This isn't actually any different than thinking about up above how we really have 7 letters and we need to assign them to boxes A, B, or C. And letter 1 goes to B, letter 2 to C. The same as T going to B, U to C. We just gave them more specific names. So we're doing the same thinking, the problem's kind of disguised it. That was all I had. I hope that made some sense. If it didn't, please reach out on Piazza, come to office hours. If it did make some sense, also let me know on Piazza. I'm not really sure and I want to get better at this, and that would help a lot. And if it made no sense, that would also help me a lot. Good luck with whatever studying you can manage to do this weekend. I'm sorry you have an exam next week. Not that this helps, but there's been a lot of talk. The professors recognize that it's almost impossible to study this week and weekend. It's been generally pretty impossible to learn this whole semester. They're working on plans to at least soften the blow of things, hopefully. We'll just see, like nothing is set in stone yet. I can't promise anything. But I'm really sorry. It sucks. I hope you're safe this weekend. I hope things are as okay as they can be. I'm not really okay right now. But if there is anything, if you think we just have to do that studying, please let us know. And on that somber note, I should end this video. So, bye y'all. Good luck.